Biuret test is a chemical test used for detecting the presence of what? The first question we'll be looking at. Biuret test actually used to detect peptide bonds in proteins. So B is correct. So how is it done? Sodium hydroxide is added to the test sample, followed by copper 2 sulfate. Copper 2 sulfate is blue in color, and then sometimes sodium tartrate is equally added, and heat is applied. If the mixture retains the color of copper 2 sulfate, it means that there are no peptide bonds, or there are no proteins. Peptide bonds make up proteins. It means there are no peptide bonds. But if there's a color change to a violet color, purple color, peptide bonds are present in the sample. So the answer is B, proteins. Okay, let's just quickly explore common food tests. Test for starch, usually done by iodine solution. A few drops of iodine solution is added to the food sample. If a blue-black coloration is produced, it means that starch is present. Iodine forms a complex with starch, and then the color is blue-black, kind of. Okay, something like this. So when iodine solution is added, a blue-black is a coloration, is a positive test. It means the substance contains starch. Okay, and then the next test is test for reducing sugar. We use Benedict solution. The food sample is mixed with Benedict solution and heated in a water bath, something like this. If the color changes from blue to green, yellow, or usually brick red, it means that reducing sugars are present. Now somebody may be asking, what are reducing sugars? Reducing sugars are sugars that can bring about reduction. They are in essence electron donors. They can bring about reduction, and they can reduce weak oxidizing agents. Examples are glucose, maltose, fructose, galactose. They are reducing sugars. So they give a brick red coloration, or an orange coloration, yellow coloration, or even green coloration with Benedict solution. Okay, test for lipids, emulsion test. The food sample is mixed with ethanol, and then water is added. If a milky white emulsion is produced, it means that the sample contains lipid. So that's how we test for lipid. Don't forget, for reducing sugar, Benedict test can be used to identify the presence of a reducing sugar, iodine test for starch, and then emulsion tests for lipids. Okay, non-reducing sugars are sugars that will not bring about reduction. They do not react with weak oxidizing agents. But if we are to test for non-reducing sugar, the sugar must be hydrolyzed before the test can be carried out. Sugars are hydrolyzed by adding dilute hydrochloric acid to them, and then neutralizing the excess acid with sodium bicarbonate before performing Benedict tests. So if it tests positive after all this to Benedict test, it means the sugar was a non-reducing sugar. So take notes. Okay, millions reagent is used to test for proteins. The essence is to detect tyrosine residues in proteins. Tyrosine is an amino acid that exists in proteins, and then very common in hormones, very common in muscle fibers, and in egg, albumin in egg, etc. It's found in so many proteins in animals and even in plants, nuts in plants. You see this amino acid forming the proteins that make up those plants. So millions reagent is made up of mercuric nitrate in nitric acid. So the full sample is placed in a test tube and millions reagent is added and then heated gently in a water bath. A reddish brown color indicates the presence of tyrosine containing proteins. So this is very important. Bi-red test for peptide bonds, but millions test for tyrosine residues in proteins. Okay, the next question is, a gas when mixed with oxygen, it produces a very hot and easily controllable flame. What is the name of the flame and where is it used? Okay, the flame is oxyacetylene flame. Oxyacetylene flame is used to cut and weld metals, more or less like what you are seeing in the image. So you probably must have seen metal workers doing this. They'll put on the flame, adjust it, can be used to bore holes in metals, can be used to cut metals, can be used to join metals together. The name of that flame is oxyacetylene flame. Oxygen is mixed with ethane and then is used. It produces a very hot flame to about 2000 degrees Celsius, and that can cut and weld metals. So the answer is D, please. Okay, the number of geometrical isomers in butene are 2. This is butene. Geometrical isomers are isomers that are formed by differences in conformation around a double bond. So these two are both 2 in, but the configuration around the double bond differs. For example, similar groups are on one side in this conformation, in this conformation, and then similar groups are on opposite sides. Here, hydrogen and hydrogen are at the upper part of the molecule, and then methyl group are the lower part of the molecule. So, but in this one, they are at opposite sides. So this is called cis but 2 in, and this is called trans but 2 in. So these are, we call them geometrical isomers. They are not the same molecule. The conformation makes them differ. They have the same molecular formula, but different arrangements around the double bond. Okay, how many isomers has the organic compound represented by the formula? This. So you just need to draw molecules with 3 carbon and 8 hydrogen. So one of them will be propan-1-ol, CH3, CH2, CH2OH. So you just draw. As you can see, there are 3 carbons, 8 hydrogen in all, and 1 oxygen. So and then the OH group is the functional group. It's at the first carbon. So this is propan-1-ol. Also propan-2-ol when the OH group is at the second carbon, attached to the second carbon. So if you count the number of carbon and hydrogen here and oxygen, you see that they conform to this molecular formula. And then methoxyethane. Methoxy, this is methyl group, and then there's an oxygen, and there's an ethane or ethyl group from an ethane. So if you count, you see that there are 3 carbon, 8 hydrogen, and 1 oxygen. So the right answer is B, 3 isomers with this formula. Okay. When a few drops of millions reagent is added to egg white solution in the test tube, the white precipitate changes to, so remember the millions test we spoke about earlier. So when millions reagent is added, the color change is reddish brown in color. Reddish brown in color when millions reagent is added. Okay, if the solubility of potassium nitrate at 30 degrees Celsius is this, a solution containing 303 gram per dm cube is likely to be. So what you do is to calculate the molar concentration of this. So the formula is, this is the mass concentration, and then the solubility is expressed in molar concentration. So the formula is mass concentration divided by molar mass, basically. So this is the mass concentration, and then this is the molar mass, and this is how you calculate the molar mass. So the molar mass of potassium nitrate is 101 gram per mole, and then the mass concentration has been given to be 303. 303 divided by 101 is approximately 3.00 mole per dm cube. 3.00 mole per dm cube is less than the solubility of potassium nitrate. As such, the solution is not saturated yet, it's still unsaturated. What it means is that more of the solute can still dissolve at that temperature. So because with the solubility that was given is 3.10, it means that it can take 3.10 mole of the substance in 1 dm cube of the solution at that temperature. So the answer is B. Okay. Number 6, 127 gram of sodium chloride was dissolved in 1 dm cube of distilled water at 25 degrees Celsius. Determine the solubility in mole per dm cube of sodium chloride at that temperature. So the mass of sodium chloride that was dissolved and the volume was given. So the solubility in mole per dm cube. So all you need do is to convert this to moles. The formula is number of moles is mass over molar mass. So you need to find the molar mass of sodium chloride, and then divide this by it, and then when you are done, you find the concentration in mole per dm cube. You already have the number, you would have had the number of moles, and then you divide it by the volume, which happens to be 1 dm cube, to get the solubility in mole per dm cube. So you can pause the video and test yourself to see if you will get it. Okay, if you have done that, this is my solution. So you check if it's the same with what you did. Total mass of sodium chloride as molar mass is this, and then number of moles of sodium chloride is approximately 2.17 mole when you divide, and then when you find the solubility by dividing it by 1 dm cube, it becomes 2.17 mole per dm cube. There's no 2.17 mole per dm cube, but 2.17 is approximately 2.2 mole per dm cube. So the answer should be C. Okay, the quantity of electricity required to deposit 180 gram of silver from a molten silver triazonitrate 5 is okay, using Faraday's laws of electrolysis. So the first thing to do is to calculate the moles of silver. So how many moles of silver do we have from here? 180 gram. Remember, the number of moles is mass over molar mass. The molar mass is 108 grams. So the number of moles will be 180 over 108, which is 1.67 moles. And then from the equation of the reaction, silver is forms an ion with a single charge. So to discharge silver, it means one silver atom will gain one electron to form one silver atom, or we can say 1 mole of silver ions will gain 1 mole of electrons to form 1 mole of silver. So 1 mole of electrons is 96,500 coulombs of electricity, or it is equal to 1 Faraday. 2 mole of electron is equal to 2 Faradays. So as such, since we have 1.67 mole of electrons from what we have here, 1.67 mole of electrons, because 180 gram was used. So if the mass of silver is 108 gram, which is 1 mole, it will be 1 mole of electron. If it is 1.67 mole, as it is in this case, to be 1.67 mole of electron. So, and as such, which happens to be 1.67 Faradays. So C is the answer. What would be the order of the electrolytic cell in an industry intending the production of silver plated spoons? So basically this is how the setup is to plate silver. Electrolytic cell is set up using silver nitrate or any soluble silver salt. The spoon is used as the cathode, while the silver that is to be used to plate the spoon is used as the anode. This is because oxidation always occurs at the anode, and then it is expected that the anode will lose electrons. The anode will lose electrons to form silver ions. So when that happens, the silver will dissolve, and then it will now go and gain electrons from the cathode and become deposited on the cathode. So so that is why the spoon will be the cathode, and then the silver will be the anode. Oxidation, don't forget, always occurs at the anode. So if silver loses electrons in the anode, it will form silver ions, and then the silver ions will migrate to the cathode and accept electrons and become deposited on the cathode. So that is why the anode has to be the silver, and then the cathode has to be the spoon to be electroplated. So A says cathode is the spoon, anode is the silver, and then electrolyte has to be the salt of silver. That's how electroplating is done. So the answer is A. Okay, the table above shows the formula of some ions. In which of these compound is the formula not correct? So formula of some ions: aluminium tetraoxosulfate 6. So aluminium is +3, tetraoxosulfate 6 is -2. When they exchange valencies, these 2 will go to Al and these 3 will come to SO4. So as you can see, so this is correct. Calcium triazonitrate 5, calcium, and then this triazonitrate 5. Calcium is +2, triazonitrate 5 is -1. This 1 will come here and this 2 will come here. So calcium triazonitrate 5 should be CaNO32. CaNO32, this is correct. And then the next one is iron 3 bromide. This is iron 3, and then this is bromide. Iron is +3, bromide is -1. They will exchange oxidation states when they react. That's the easiest way to write the formula of the compound. So bromine will be 3, iron will be 1. So FeBr3. So the answer here should be C. Okay, on the pH of a 0.001 mole per dm cube of tetraoxosulfate 6 acid is what the formula for pH? Formula for pH is logarithm to base 10 of the hydrogen ion concentration. So however, the acid in question produces 2 hydrogen ions per molecule of the acid. So according to this equation, so that means 0.001 mole per dm cube of H2SO4 will produce 0.002 mole per dm cube of hydrogen ions, because for every 1 mole of the acid, 2 moles of hydrogen ions are produced. So that's what is being explained here. Okay, so the pH. So since we have gotten the concentration of the hydrogen ions to be 0.002, pH becomes negative logarithm to base 10 of the hydrogen ions concentration. So pH minus log to base 10 of 0.002. If you write 0.002 in standard form, this is what you will have. Remember the laws of logarithm. When you have log of a product of 2 numbers is equal to the sum of their logarithm. So log 2 plus log 10 to power minus 3. Log 10 to power minus 3 is minus 3, and then log 2, according to the question, was given as 0.3. So when you add both of them, you get minus 2.7, and eventually, because of the negative sign outside, the pH becomes 2.7. So the answer is A. Thank you for your time.